At the beginning of each module, I'll ask you to open up a playground file like this one. That file will contain the examples I will walk through so you can follow along. A second file will contain exercises for you to do on your own. You can download all the files for the course from the link in the instructor's notes at the beginning of each lesson. Go ahead and download the playground files for Lesson 1 now. Then, open up the file entitled Lesson 1, Types and Operators. If your playground doesn't look like this, but instead has a bunch of green comments, you'll want to change one of the settings up here in the Editor menu. Go down to here where my menu says Show Raw Markup. Yours might say Show Rendered Markup. So you'll want to click on it if it says Show Rendered Markup. Then it should look like this. I'm going to start by quickly running through the definitions of Swift's primitive types. Swift's primitive types don't have too many surprises. Here in this light switch class, the on property is a bool. Swift booleans always have a value of true or false. They can't be assigned to 0 or 1 as in C, or yes or no as in Objective-C. If you don't recognize any of this syntax, don't worry, that's to be expected. I'll explain class and property definitions soon, along with this dot syntax. For now, just focus on the data types. For properties that need to hold continuous values, we might want to use the int type, which holds an integer. For example, if our light switch had a dimmer, I'll give our light switch a dimmer property, and then I'll set that dimmer property to be of type int. What if we wanted to set our dimmer to pi? If we want this dimmer property to be able to represent decimals, we can try using a float instead of an int. Of course, if we use a double, then we can get a more precise representation of pi. Here I've carried it out to 11 digits. Between float and double, you can decide which type to use based on the level of precision you need. Strings and characters in Swift are pretty much as you would expect. Naturally, the character type holds a single character, and the string type represents an ordered collection of characters. The Swift string type comes with a handy bag of tricks that make string manipulations nice and concise, like this simple string concatenation. Here in the playground sidebar, you can see the concatenated string. We'll have more fun with strings in the exercises at the end of the lesson. There are two other Swift types that require a deeper dive. The first is the optional type, which is the focus of the next lesson. And the second is tuples, which we'll talk about in the collections lesson. For now, just know of their existence. Before we finish, there's a secret I haven't revealed. See how I've indicated the type for each of these variables? I can actually take all of these type indicators out. But the compiler is having no problem inferring the correct type. And we can even test that by taking a look at the type of these variables. Let's try this concatenated string. This dynamic type property can be used to investigate any object's type. And we can see over here in the sidebar that the type of concatenated string is a Swift string. And the compiler was able to infer that even though we didn't indicate it directly in the definition. In the upcoming quiz, you get to play the role of compiler and do some type inference of your own.